All right. Hopefully they didn't have questions on the front side. Sorry, people tuning in. We went through some questions already without you. All right. So they want us to find the value of angle A in number 7. So finding the value of the angle, especially those of you guys who are gone, this is something that you probably forgot how to do just because it's not, I think, as intuitive as just finding a side length. So if I'm looking for angle A, again, I'm going to label everything. Here's my opposite, but I don't know anything about that, so I'm not really going to use that. Here's my adjacent. Whoops, why did that switch? And then here's my hypotenuse. So since I'm trying to find angle A, I'm going to use these two. Adjacent over hypotenuse is our cosine, so that's what we're going to do the trig function for. So cosine of A, I don't know what A is right now, is adjacent over hypotenuse, so 9 over 22. Now, we want to figure out the angle is, so we have to undo cosine, and this is where you use the inverse cosine feature, which is like the button like right above your cosine in your calculator. And this will give you that angle. So you just leave that fraction the way it is. And I got like 65.9 for my angle if I round to the 10th place. And again, just double checking that you know how to put that in your calculator, that's working for you. You might have been doing something weird at one point, but like just double checking that you know, like the day of the test to come to me and say, I don't know how to enter any of this in my calculator. Or not bringing your calculator to the day of the test. I know, shocker, and then not ask me for one. So I'm pretty intimidating, so I understand that you'd be afraid of me. So I place fear in the hearts of many, and no. Oh yeah. I'm just going to put it out there. He did his pre-calc exam without a calculator. Dylan. He passed the class. I did go back and look, and there was a few I was pretty impressed with that you like a few multiple choice questions like that were trig, and then he looked at it and he was kind of like, that looks about right, and he actually did. Like, but the ones that were like open. I had no idea. I don't know how I didn't notice you weren't using a calculator the whole time. I think I would have just handed you one because I would have been so frustrated with you, but I don't know. Anyway, so in number 10, we're supposed to solve this triangle. So that means find all the missing sides and angles. So I don't know U, I don't know E, and I don't know UM. So I have to find all those. So UM, you could probably find with Pythagorean theorem. It's probably the easiest, fastest way. It's kind of up to you, though, how you guys want to go about that. But some of you, once you learn trig pretty well, though, you might prefer trig over Pythagorean theorem. So I get x squared is 99, and then it's the square root of 99. .94, so 9.9. And then now we're going to find our angles, and again, that's just like the one we did before with the inverse. So if I'm finding angle U first, it doesn't matter which one you go for. This is my opposite. This is my hypotenuse. Now I know this one now, but I'm probably not going to use it exact if I can, and 18 and 15 are exact numbers. So I'm going to use opposite and hypotenuse. I'm going to use so. So I'm going to do sine of U equals opposite over hypotenuse. And then in order to solve that, we're going to use the inverse sign. And then it'll give me the value for U, which is about 56.4 degrees. And once I know that, I'm not going to do trig because I know the angles of a triangle add up to 180. So I'm just going to take this away, and then this should be 33.6 degrees. All right, and then we'll go to number 12, and then we're done with our homework questions. All right, so in number 12, they want us to draw the picture. So they tell us angle C is 90, angle A is 40, and then little a is 6. And we're going to talk about this more today, but if I draw this triangle, C would be our 90, A is going to be 40, so I'm just going to call this one 40. Then little a is across from big A, so that would make this 6. So the same letters across from its same side, like same angle or whatever. So I need to still find little c, little b, big B. Now the angle should be easy because I know they add to 180. So that would make this 50. And then I need to find little b and little c. So this time I might show you guys how I'm going to change my perspective, because if I call this my opposite side, that means it's going to be on the top of my fraction. So instead, I'm going to use this one and call this my opposite side and this one my adjacent. That's a way to flip it so that my known side is on the bottom of the fraction. So I'm going to do tangent of 50 equals opposite, which is little b, which looked like a 6, sorry, over 6. And when I go to solve this, I don't have to do the cross multiply thing. I can just multiply each side by 6. So now b is 6 times the tangent of 50. And then again, once I know that, then I can use Pythagorean theorem to find c. Or another trig ratio. It's up to you. All right, so hopefully those of you guys who are gone, that was like our class in a nutshell yesterday. So hopefully that was a good enough review. And it kind of jogged your memory, because I know you guys have learned this before. Now, what we're going to talk about today is something that might have been hit or miss depending on like COVID and who you had for Algebra 2 and what you made through, because this is not just a geometry topic, this is typically Algebra 2. Or if you've had pre-calc, this is probably the exact same lesson I taught in pre-calc before, so sorry, it's going to be maybe slightly boring. I mean, not that math's ever boring.
What about your mom? Talking to your mom? Matthew wants to talk to your mom. Would you like to know?
Don't even get me started on this one.
Matthew, not me. Oh. What's the date? What's the
You gotta oh, it's a pit, Paul. It's a pit. I'm sorry.
I'm sorry. I'm sorry.
Yeah.
That I don't agree with. That is something I very much appreciate. Yeah, I agree. Like compared
That's
like
great.
the
Yeah,
notes
it
in
was
Mr. Hatfield. Oh, it's all. Oh my
Once you
god.
trip them.
Oh yeah, I know. Yeah.
Children pretty good at saying. No, I moved it. I moved it where I moved it.
You're not going to say thank you?
Really? I didn't think so. Yeah. Up north it was.
I need a new hair.
You need a haircut?
I want to know that.
Same work, yeah.
No? I don't think so. Especially like this. Is that pretty nice? You're supposed to like all over like It's because I use a hair dryer.
I see my hair dries. I don't do that.
Once it goes into formation, she doesn't leave. Okay, I go like this.
I gotta go.
And I come back and just like that. Sometimes it gets droopy though.
I'm sorry, what?
Yeah, that's a story for
That's
today.
the latch just isn't tucked in.
Oh, Haley Bumper.
I was just like, because if I do anything else, like my hair in the back was like, my front
It's beautiful.
Okay, guys, so just to save a little bit of time, why don't we change this up a little bit? Why don't we find, in letter A, let's find the value of x, and then this one, we're going to find the value of theta. That's just that angle. It's just a fancy name for the angle.
Oh yeah, I remember.
So find x there and find theta there. So the one you're just finding the side length, and the other one you're just finding the angle. So to save on time, it doesn't need to solve, but just find the one side in the one and then the one angle in the other. Oops, no. These are actually both the same trig function if you use the angle that's like marked. So you're finding, the one you find x, in that case you're finding a different side. So you're finding the opposite. That's the hypotenuse.
So I got you.
Yeah. So then you could use pentagram here to find the mean.
What'd you do?
That would be opposite over hypotenuse, so you don't know either of those.
Yeah.
So you want to look for this. You have the adjacent. Beta, dark beta. It's like it's TH. Beta.
Oh wait. Oh come on. Hold on. I got no. I was going for the wrong.
Did you get 30?
No.
You got 30?
I got the wrong.
25.
I went for the wrong.
25. 27. Correct. Yeah.
I did not get 30.
Yes, you did.
I specifically remember.
Yeah, so you do cosine, right? Cosine.
Well, you remember you saying you got 25.
No, it's
It'll equal this
No,
thing.
you don't.
Oh, you. Oh, you're right. Right.
Is that what?
This is where, yeah, this is where you do the
I didn't
inverse
get
of
25.
that.
No, yeah, so.
It's right above. Okay, guys.
I got
So-
okay, good.
In both of these, they don't tell you anything about the opposite side. So the opposite side is completely out of this problem unless you wanted to go about it a longer way. So we're avoiding the opposite. The only trig function that doesn't use the opposite is the cosine. So here we're going to do the cosine of 28, because we know the angle equals the adjacent over the hypotenuse. Now, this is not the only way to get the answer, but this is probably the most straightforward way. There's other ways to go about it. This is probably the way that the majority of you do this. However, I'm not saying that's the only way, and it's okay to go a different route with it, as long as you get the same answer. So cross multiply. So I get x times cosine of 28 equals 29.3. Sometimes my board has a moment. And then I'm going to divide by the cosine of 28. And again, if you're comfortable skipping some steps here, I'm okay with that as long as your work ends up okay. And so we get like 33 point something, right?
Yup.
Okay, so 33.2. Okay. And in that one, we were finding a side length, so we don't have to do the degrees or anything like that. We kind of go back and look at the problem and say, well, yeah, that makes some sense because that's the hypotenuse. It should be the longest side, so kind of being a little bit, strategic about that. Whereas now this one, we're trying to find the angle. So this theta, this little weird symbol. So we're doing cosine again because it's the only one that doesn't use opposite. Cosine of this little theta thing equals the adjacent over the hypotenuse. And once you get the hang of this type, these are pretty easy to do, but like I said, it's not like if you've never been in a trig class or math class before, you'd be like, oh yeah, I should use that inverse cosine now. But it's not just logical, but that's what we need to do. So we do the inverse cosine of 4.4 over 11, just like that division, and we find out this angle is going to be about 66.4 degrees.
No.
Luke can come in for intervention in two Fridays.
Way to go.
That's tough. Maybe if you just think in 38.
All right, questions there at all? All right, so we're going to talk about now is how to find sides and angles of non-right triangles. So SOHCAHTOA works awesome for right triangles. However, non-right, we need a new rule. So we have this law of sines and law of cosines that helps us with this. So, law of sines, and like I said, this is something you might have seen before or something that you've never heard of, and at the same time, you'll be okay either way. So just know that if I'm going more slowly and you've never seen it, that's probably for you, but let me know if you still need some more help. So, what the law of sines is, this is for non-right triangles. That's really important. Every once in a while, I'll show students law of sines, and then they start using it for all triangles, which it does work still for right triangles. It's kind of like an extra step that you really don't need. So this is what the law of sines looks like. Three of these fractions, you only need two of them, or two of the ratios. Oh, not cosine. Sorry. Now that's supposed to be a capital C there, not super clear on my board here. So the A, B, and C are angles. Capital A, B, and C are angles. So those little sides are the sides across from those angles. So this is my triangle. My angles are the big letters. And then the sides are going to be the little letters, but they're going to be across from, so like little c is across from big C. Little a, little b, they're across from their corresponding angle or side. Now, by default, I try to use law of sines if I can. There's some problems that we'll have to use another type, but that's when we'll get to the back side. That's our law of cosines. Law of sines is the easier of the two laws we're going to learn today. And again, this is for non-right triangles. So when we're kind of stuck, we can't use our SOHCAHTOA anymore, we can use these. So we're going to get into that now. So it says to solve the triangle, we're going to find all sides and angles. We'll kind of just start maybe a little more simply though to begin with. So they have this 118-degree angle here. So clearly we don't have a 90-degree angle. So that's how we know we're not using SOHCAHTOA. So 118 is going to be across from little a. That's the side that's across from that angle. 22 is going to be across from little b, which I don't know. And then big C is across from 24, but I actually know that already, don't I? Mm-hmm. Yeah, we know they add to 180 degrees. So if I have 118 and 22, I can take that away from 180. It's Friday, so I'm going to subtract in my calculator. So it's 40, right? So that's going to be a 40-degree angle. So we already found angle C. Now, we're going to set up law of sines. And again, we only need 2 out of the 3 of these ratios. I'm actually going to use angle C because I know that one already. So I'm going to do sine of 40. What is it going to go over? 24. That's the side that goes with that angle. Does that make sense? So the 24 is across from it, so it goes in that same part of the ratio. Then I'm going to choose one of my other sides to go for. I don't know, A. So sine of 118 goes with which one? A. So little a goes with sine of 118. So this allows me to solve this problem, and this is just a proportion, so this shouldn't be like something that totally Greek to you. Obviously the signs make it a little tougher, but hopefully not too bad. The swallers have a loud sneeze. So I cross multiplying these together. And I want to get a alone. It's being multiplied by the sine of 40. So instead I'm going to divide by the sine of 40. Because that has to move kind of as one piece. So now this is kind of a lesson in your calculator as well. We have to make sure your calculator and you are working together on this, that you put this in correctly. So be really careful with this. A lot of times you might have to close this parenthesis off, maybe if your calculator is asking for like a parenthesis there. I'll show you guys what you should get as an answer, and then hopefully you can figure out what you're doing wrong if you didn't get it. Actually, it should be 33. I can go round up to. Yeah. So it's 33.96, so like we'd round up that to 33. So if you're not getting in your calculator, we have to figure out what you're doing wrong. Your face says it all. So, yeah, that would do it. Use the right numbers, that helps it. Yeah, because then we round it up to 30.
I know what you did. You got 38.
No, I did not.
The answer is always 38. We get 33. Yeah, we're good. Oh, okay. Oh, sorry.
You got 38.
The poor guy's never going to want to ask for help because you guys are all bullying him.
Well, how do you even do it? He actually points out.
Alright, how are we doing? Are we figuring it out? And yeah, this is kind of like making sure your calculator is doing what you're asking it to do. Sorry. We okay there? Alright, Now, if we wanted to find angle B, we could do that as well, and it asks us to solve the triangle, so let's finish off with angle B here. I know there's not probably a ton of room. We have, again, B is across from 22, so we just do sine of 22 over B. Now we can't do Pythagorean theorem on this one because it's not a right triangle. We know two of the sides. We're so used to Pythagorean theorem, but we can't use that. Now I'm going to use sine of 40 over 24 because 33, although it's a pretty nice number, is not exact. So I prefer to use exact numbers. I leave my calculator lots of places. Just put it down when I laughed at Carter. 14, yeah, it rounds nicely again. All right, so you guys get that as well? That work out? Where'd the weight come from? Huh? Okay, someone say weight. Yeah. Yes. Mm-hmm.
What'd you get? What'd you get?
For which one? I'm so confused.
What is your problem? Oh, you're on B.
I'm not done with them.
I just started it actually. Wait, we're supposed to start.
Yeah.
For regular feet, I got 13. Like 19.
All right. Let's do one more and then we'll take a break, Dylan, okay? One more. Hang in there. Okay. No, 140 is so long. You go down, you go down, you go back to back. I do. That's usually part of my break. What's part of your break? Reading the announcements. Yeah, what is break? After this example. Okay. Go. All right. So after this example. Oh my goodness. Okay. So, all right. So in this next problem, this is a little bit tougher one. This 97 matches up with 22, which seems good, except we don't know either of the other two angles. We do know the other two sides. So I'm going to set this up.
Wait, the 19 lines equals C and 9 of B?
Yeah. So let's start with angle C maybe. It doesn't matter. But now I have to set this up where I don't know angle C. So this one's going to require a little bit more work on this step. The last step is a little bit easier. We don't have to do law of sines again. But when I go to cross multiply here, just be careful. Our unknowns with the sign. That's got to stay with sign. So we're going to cross multiply here. I want to get that sine of C alone. So we're going to divide by 22. Very good. So we divided by 22. And in order to figure out what C is now, though, I have this sine of C equals this huge kind of ugly fraction here. When I'm trying to find the angle, this is where we bring the inverse in. So anytime I'm trying to get rid of that sign now, to figure out C, I'm going to do the inverse sign of this huge ugly fraction. So this is another time just making sure you guys have this written well in your calculator. Because we're finding an angle now instead of like a side. Now you should be able to put this all in at once. You might have to break it into 2 parts depending on your calculator skills. See where your skills are. Yeah. She's a mathematical genius. She actually goes and counts cards at Las Vegas on the weekends.
He's not with, I don't know why that is a big thing. Yeah, 62.
I have to see, like, there's some paper and pencil ones to do. I don't know if there's any, like, text group that's meeting at my last.
So you got 62. You got 63.
Yeah.
There's not 63.
Still, yeah.
We almost died. Is that the almost died one?
Yeah, I think
Okay. All right. So guys, I got 59 degrees for angle C. That you guys got?
Not
Yeah.
Luke.
We've got 38 again. Okay. Once we know angle C and we know angle A already, we don't have to do law of sines again. We can just know that they all add up to 180 degrees. So we can just kind of take that away. So for angle B, we can figure that out. So 24, yeah. Okay.
What do you Celsius?